Hi everyone, thanks for taking the time to join us on this webinar focusing on our predictive analytics software HanPHI catches. Today we'll discuss what our solution is and how our solution HanPHI improves plant operation by increasing lead time for maintenance activities. My name is Sarah Klein and I'm the General Manager here at HanPHI Software in Austin, Texas, and I'm with one of our customer support engineers, Chris Merrick, who will later give a brief demo of our solution HanPHI. Some background on our company: HanPHI Software provides optimized software solutions to help the process industry improve plant management and maintenance. The purpose of our tools is to enable active monitoring and give plant personnel and management a more complete view of the plant's condition. HanPHI enables organizations to detect hidden and potential failures in advance. It uses advanced pattern recognition and unsupervised machine learning to recognize anomalies in a plant, system, piece of equipment, all the way down to the sensor level. This is great, but what does it actually mean? Let's say you're in a plant and you have to go to each piece of equipment and check on it to determine whether or not it's sick. This will take time and require you to do significant analysis. But what if your equipment could raise its hand and say, "I'm sick"? This is the same idea of HanPHI. HanPHI gives voice to your equipment so that it can tell you its current status. For our solution HanPHI, our customers see reduced non-productive time and downtime, increased labor efficiency and plant safety, and decreased maintenance costs. How? By eliminating potential and hidden failures in advance. For example, one of our clients saw over $4 million in savings in a little over 2 years by using our software. The potential ROI is significant, but the people aspect is also key. Our president likes to describe our solution as a personal assistant. It helps you do your job better and more easily. Work smarter, not longer. For example, one of our current clients faced a time limitation. They could analyze all the equipment on a rolling basis, or they could analyze select equipment all the time. With HanPHI, they're able to analyze all the equipment all the time and have their people prioritize maintenance and monitoring. Much better, right? The other aspect is plant safety. I was at a panel last year and someone asked a plant manager what keeps them up at night. It wasn't related to money or efficiency. It was, are they going to get a call that someone was hurt on site? By eliminating failures before they happen, you keep your personnel from having to react to a failure, which introduces a host of issues. If you're ready to add advanced pattern recognition into your strategy, our Plant Health Index solution, HanPHI, alerts users of potential problems at a plant before it occurs. It focuses on the current condition of the plant, not the ideal plant that exists in a vacuum. HanPHI uses an empirical data model that learns historical, fault-free, normal operation data to create patterns. This solution identifies small deviations in equipment and operation behavior that are precursors to potential and/or hidden failures. As previously mentioned, the predictive data model uses fault-free, normal operation data collected and stored by the historian. Here, the variables are read, and the model executor then calculates expected values, residuals, and health index of each process variable, piece of equipment, and the entire plant. But information isn't useful unless it's easy accessible and understandable. So the solution displays the health index in intuitive hierarchical order to help focus the user on the root cause variable. And if the solution detects an anomaly, an early warning is generated. At the core of this technology is its ability to detect several thousand unique patterns based on the historical plant data. These patterns let you understand what the current value of the tag is in relation to the operating condition. And the solution doesn't require a pattern for every single instance of every single condition. The solution uses the intelligence and algorithms to predict a pattern for conditions not contained in a set pattern. HanPHI uses an empirical data model that learns historical fault-free normal operation data to create patterns. This solution identifies small deviations in equipment and operation behavior that are precursors to potential and/or hidden failures. The predictive data model uses data collected and stored by the historian. Here, the variables are read, and the model executor then calculates the expected values, residuals, and health index of each process variable, piece of equipment, and the entire plant. But information isn't useful unless it's easily accessible and understandable. So the solution displays the health index in an intuitive hierarchical order to help focus the user on the root cause variable. And if the solution detects an anomaly, an early warning is generated. At the core of this technology is its ability to detect several thousand unique patterns based on the historical plant data. These patterns let you understand what the current value of the tag is in relation to the operating condition. And the solution doesn't require a pattern for every single instance of every single condition. The solution uses its intelligence and algorithms to predict a pattern for conditions not contained in a set pattern. On the screen now are the fundamentals of HanPHI's predictive data modeling. The operational data that reflects the plant status is collected from the DCS, or Data Acquisition System. A predictive model is constructed by using correlation algorithms based on the data. The correlation algorithms are used to differentiate and analyze the correlation between signals that affect each other, and any abnormal data is removed so as to not skew the predictive data modeling. For example, the bearing temperature and vibration in a turbine and the temperature and pressure in a turbine shaft are all related signals, so they can be grouped into a turbine group. Other signals may be grouped together when they are designed to automatically or manually adjust to prevent drastic increases or decreases. Finally, general properties should be considered, like the relationship between flow rate, temperature, and pressure. Once completed, the selected data reflects the physical and empirical properties of the signal itself. Through this process, a series of groups are created. Since patterns are based on normal operating data of the plant, the model also reflects the operating environment of the plant and equipment. For example, the model considers the seasons. The pattern for the summer season looks different than the pattern for the winter season. Finally, the predictive model must be optimized. Even if there's a subtle change in signal value, it can be a very important change. And even if there's a sudden change, it may be a natural change in the characteristics of the signal. When the prediction model is executed, the real-time values are compared with expected values to calculate the residual. The difference is expressed as an index from 0 to 100%, and the greater the difference between actual and expected, the closer to 0 the value. Again, information is useless if it's not easily accessible or understood. So this easy-to-understand health index gives all levels of the organization a better understanding of the current plant status. What's important to note about HanPHI is that it provides early warnings regardless of what the DCS alarm level is set to. Existing alarms like the DCS generate an alarm when the value reaches a specified alarm set point, regardless of the external environment, load, or season. In contrast, HanPHI and our advanced pattern recognition considers all of this to provide early warnings. When a DCS alarm occurs, it may be too late to act as the breakdown is imminent, causing equipment damage and loss of money and time. In contrast, HanPHI provides added lead time to respond to exacerbating equipment conditions, transforming reactive maintenance to predictive maintenance. So all of this information is great, but if you're going to implement a solution, how are you going to pay for it? With any software, especially predictive maintenance solutions, it's important to understand the potential ROI. For our solution, some items to consider are the cost of replacing a piece of equipment or system, productivity loss of personnel reacting, overtime when reacting to a failure, and labor required when doing corrective or preventive maintenance. Now let's look at some actual cases from our customers. On the cost-saving side, these are a few examples of savings from our customers. In all of these examples, what is important to note is that HanPHI resulted in early notifications of anomalies. With extended lead time, the plants were able to take the necessary actions to avoid unplanned downtime. So let's do a deep dive into each of these examples. The first case is from October 2017 when HanPHI helped an 800 megawatt thermal power plant save over $110,000 in maintenance costs by providing early warnings of a potential booster fan trip. In May, HanPHI detected an anomaly in the booster fan vibration. Vibration X fluctuated from 13.2 millimeters per second to 0 millimeters per second when HanPHI expected the vibration to be at 3 millimeters per second. Vibration Y also fluctuated, reaching a maximum of 16.3 millimeters per second when HanPHI expected the vibration to be at 3.4 millimeters per second. Though vibration X and Y were fluctuating, the fan inboard vibrations were normal. The manufacturer inspected the instruments, sensing lines, and terminal block, but did not find anything. The site assumed that electrical cable damage had caused the malfunction and decided to replace it during the next overhaul. But on October 7, HanPHI identified booster fan vibration hunting. Vibration X increased from 1.7 millimeters per second to 3.5 millimeters per second, and vibration Y increased from 1.8 millimeters per second to 2.6 millimeters per second, while fan inboard vibrations remained normal. At this moment, the site confirmed equipment misalignment and acted. The second case occurred in February 2017 when HanPHI helped an 800 megawatt thermal power plant save approximately $80,750 in maintenance and operation costs by providing early warnings of increased turbine bearing vibrations. After an overhaul, HanPHI identified a vibration issue on one of the turbine bearings. The vibration was 81.6, while HanPHI's model expected 40.9 based on the current plant condition. The site continued to monitor the vibration, but 3 weeks later, HanPHI generated early warnings for increased vibrations on this bearing and 2 additional turbine bearings. During this time, one of the turbine bearings' vibration gradually increased to as high as 131.8 and continued to fluctuate according to output. In its current condition, HanPHI expected the normal bearing vibration to be 102.1. After investigation, the site determined that there was an assembly problem and fixed the bearing seatings. With HanPHI, the site not only resolved the vibration increase, but had enough lead time to schedule and determine the necessary maintenance. The third case occurred in 2015 when HanPHI helped a 560 megawatt thermal power plant save over $286,000 in maintenance and operation costs by stopping a potential circulating water pump trip. HanPHI identified a vibration increase on a guide bearing and circulation water pump on March 9th. The guide bearing vibration increased to 350 when HanPHI expected the vibration to be 192, while the motor vibration increased from 100 to 280. The site decided to check the vibrations weekly. After checking the vibrations weekly, the site utilized HanPHI to determine a steady vibration increase in April. The site prepared a spare motor to replace the motor in case the vibration rose to a certain level and planned motor replacement over the next month's overhaul. With HanPHI, the plant prioritized maintenance and planned for future overhauls. The fourth case occurred in February 2016 when HanPHI helped a 560 megawatt thermal power plant save over $50,000 by preventing a pulverizer trip. On February 3rd, HanPHI identified a temperature increase of the lubricating oil for the plant's 2 pulverizers. The temperature of the lubricating oil for one pulverizer increased from 36.5 degrees Celsius to 52.8 degrees Celsius, and the lubricating oil tank temperature increased from 41.9 degrees Celsius to 50.4 degrees Celsius. The temperature of the lubricating oil and tank for the other pulverizer increased as well, dropping the signal's health index to 72.7%. After receiving HanPHI notifications, the Centralized Monitoring and Diagnostics Center immediately notified the site of the increasing temperature. After pulverizer maintenance, the site had closed the cooler outlet valve to rapidly increase the temperature, but forgot to reopen the valve once the lubricating oil temperature reached the desired temp. The site immediately adjusted the valve after receiving the early warning and was able to prevent a pulverizer trip that resulted from an operator error. The sixth case occurred in May 2016 when HanPHI helped an 870 megawatt thermal power plant save approximately $121,000 in maintenance and operation costs by preventing a booster fan failure. On May 26, HanPHI identified irregular increases in the booster fan vibrations. Within 4 hours, a booster fan vibration X increased to 5.6 millimeters per second, when HanPHI expected the vibration to be at 4.4 in the plant's current condition. A vibration Y also increased to 4.9 when HanPHI expected 3.8 millimeters per second. After HanPHI's early warnings, the site tested the fan open ratio and determined that there was a foreign substance on one of the fan pitches blade. After eliminating the foreign substance, the fan stabilized. Those are just a few real-world examples from our customers regarding how they use HanPHI and how it reduces their unnecessary maintenance activities. This occurs because HanPHI provides warnings early enough to take the proper action. Looking at the standard PF curve, HanPHI gives plants, even without specials analyzing the data, an early warning of a potential failure. So what does HanPHI actually look like? Chris Merrick, one of our customer support engineers, will give you a brief demo of HanPHI so you can see how it looks and works. Plants have adopted our solutions to alert its personnel of sensors, equipment, and operation failures before they happen. HanPHI can alert a plant on the system behavior in any condition and give an early warning, not of a failure condition, but of a condition that if not addressed will cause an issue. Plants see reduced unexpected equipment failures, unplanned maintenance activities, and outage time. Thanks for joining us on this webinar. If you have any additional questions, feel free to reach out.